Hello and welcome. In this video, we are going to take another look at for loops, and specifically, we are going to look at how to leverage logic inside of a for loop to complete some task, for instance, to separate out different types of data. Now, this video assumes that you've been following along a little bit with the creation and access of elements in a vector, for loops, and some of the basics of the Matlab programming language. This video is going to leverage a character vector instead of a numeric vector. Now, if you watched the earlier videos talking about character vectors, you know that essentially behind the scenes, they can be thought of as numeric vectors. Essentially, the values of the characters correspond to the numbers between 0 and 126 as they relate to the ASCII encoding. Now, we're not going to go tremendously deep into that in this particular video. I do want you to go ahead and take a look at these two links that I provided, the ASCII table in the Wikipedia article, as well as another article off of Wikipedia. In this case, I just grabbed the Matlab article. And so the first thing that we want to do is we want to take a look at the ASCII table, and we want to have a quick reminder that basically what we're going to do is we're going to leverage the values, this decimal values here, for the corresponding glyphs. And what do I mean by glyphs? Well, that's just the letters that we know, in this case, in the English language. The uppercase letters start at 65. They go all the way up to 90. The lowercase letters start at 97 and stop at 122. And what we're going to do is we're going to sort of leverage this system, this encoding, if you would, to be able to take what would be a stream of data and then break it into its parts based on a condition. In other words, what we're going to do is we're going to set up a series of if statements that will pull out or keep track of the number of uppercase letters, the number of lowercase letters. We could probably do any sort of combination here. We may also include the numbers as well as maybe punctuation. But again, I'm going to get you started on the process, and then from there, then you can figure out how to break it up further and further. And as far as what we're going to use for our sample information, well, nothing is more appropriate than using the MATLAB Wikipedia article, and that we're going to use this first sentence of the MATLAB Wikipedia article as our quote source data. In other words, basically, this is just going to be a sample representative of maybe some input data that you would get from a colleague. This just represents a good test sample for us to use. So again, before we get started, let's focus on the problem. We want to take a string of characters or a sequence of characters, or rather, let me reword that, to a collection of characters that just so happens to be a sentence that describes MATLAB in a Wikipedia article, and we want to pull it out, we want to pull out the capital letters, the lowercase letters, and numbers, and then so on. Now, we won't actually go through and store those in this video. We're just simply going to count them. All right, so let's go ahead and get started. We're going to go ahead and create a variable called contents. Again, there's nothing magic about that particular variable. I am going to go ahead and copy and paste directly from the Wikipedia article and insert then that first sentence inside of a pair of single quotes. It is going to get a little long, and maybe for purposes of your work, you might want to consider getting something a little bit shorter. But again, I needed a nice place to stop, so I just simply grabbed that first sentence. And then what you want to do is, before we go any further, just go ahead and highlight it and go ahead and run it. And you'll see that we have a 1 by 162 character vector. And again, this may change if you're doing this at a later date. Maybe the description in the Wikipedia article has changed. And so it might be shorter or longer. But more importantly, here we have a 1 by 162 character vector that we're going to now use as sample data in our logic. Now, we've got a couple of different ways that we can go about doing this. Is that we can actually leverage a little trick in MATLAB that will allow us to leverage a for loop by leveraging each of the individual characters. And we can do something like this. So for letter equal to contents. And then what I'm going to do is I'm just going to follow this up then real quick with a display and then the letter. And we're going to play around with this, and you'll see that we have to do a little bit of tweaking on this, but you could see that basically I have each one of the characters printed individually through the for loop, starting all the way back up here top with the M, which is the first character in the contents vector, going all the way down to then the period. So far we have at least one way of going through and looping through all of the characters in this character vector. However, I'd like for us to do it a slightly different way. And just for a little bit of variety, we're going to again specify our index. We're going to specify the start as being 1. In other words, we could technically control where we start doing this counting at. In this case, we do want to start at the first character. We want to increment by 1. And what we're going to do is we're going to use the length function again to get the length of the contents variable. And then we again have our end. And what we can do then is we can look at each of the letters. So we're going to say contents, parentheses, index. And again, what we're going to do is we're simply going to display them to begin with. And again, this is just a different way of accomplishing the exact same thing. And you could see that it flew by pretty fast in the command window, but effectively the same results as that first loop. Again, I'm doing this 2 different ways just so you have a little bit of variety and understand. Perhaps this longer notation is easier for you to appreciate. It's also a little more generic. Now, what we want to do is we again want to leverage the ASCII table and that I pulled up earlier, and we want to start looking first at the capital letters. And remember that the capital letters start at 65, they include 65, and they continue all the way up to 90. So let's make a couple of notes here that'll be useful for us. So uppercase, and we'll just go ahead and call it uppercase this way. And so 65 up to 90, and then lowercase. Well, if you take another look back at the Wikipedia article, you'll recognize that lowercase letters actually come after the uppercase letters. Again, we can talk a little bit more about that later on, but they go from 97 up to 122. And then you can decide what other subset of characters you would like to look at, whether it's the punctuation, whether it's the numbers, or for that matter, one of the other interesting ones that you might want to keep track of are the spaces. And so specifically a space is going to be your character 32. And so it might be just neat for you to know how many spaces are in this particular character vector. The point is that you can just add as many of these conditions as you like. And then what we'll do is we'll simply create some variables up here to keep track of how many of each we found. And so the first one is going to be our uppercase count, and we're going to set it equal to 0. And then our lowercase count is equal to 0. And then we'll have our space count also equal to 0. And I think if you've watched the earlier video, you could probably guess how this is going to play out. We're going to start off first with an if statement. Since this is going to be a combined condition or combination of checking for both 65 as well as 90, we might as well go ahead and use a pair of parentheses. What we'll do here is we'll look at our contents parentheses index, and we will check to see if it is greater than or equal to 65. And with the double ampersands here, because we have a short circuiting operation, we have our contents parentheses index, and again here less than or equal to 90. And if both of those conditions are met, well, that simply means that we have a capital letter or an uppercase letter. So we're just going to put a little note in here. So this is our uppercase. And then what we can do is we can leverage this by a little bit of copy and pasting and just changing some values here. And then an else if. So let's go ahead and start off here with our else if. And then the condition, of course, one second here. I seem to have a typo. Let's see if we can figure out where I've either mismatched some parentheses here. So where is my... So let's change these values real quick. So this is going to be 97 to 122. Ah, very interesting. I appear to have been bitten by a bug here, or not a bug, but a little bit too much help from Matlab. The new version of Matlab appears to warn you that your conditions are overlapping. That's interesting. I just now learned that. This is in 2022B. And then let's go and do another one here. This is going to be an else if our contents, parentheses, index, and that is going to be equal to 32. So in this particular case, then this is going to be lowercase, and this will indicate that this is going to be a space. And then what we can do here is under the else, well, that's just simply anything other than what we've previously identified. And let's go ahead and add in one more variable up here. We're going to call this one other count. I like to do an additional thing here. I simply like to display then whatever happens to be the other. And then what we'll do is very carefully go in and increment the appropriate variable. And so in this case, it's going to be uppercase count is equal to uppercase count plus 1. For the lowercase, well, that's pretty obvious. It's going to be the lowercase count equal to lowercase count plus 1. Likewise, with the space count is going to be equal to space count plus 1. And then lastly, under the other, well, that's going to be the other count is equal to other count plus 1. Now, the final thing that we want to do in this particular example is we would just simply like to display the results of our operation here just to prove to ourselves that we have actually done something. And again, what we can do here is a combination of the display with the sprintf, or if you like, you can do the fprintf. But what we'll do is we will start by displaying the uppercase. And we'll just do uppercase equal to, and then you do not want to forget your placeholder here, your %d. And then our uppercase count. Of course, you want to have a comma separating the two. And then we'll simply repeat this then for our lowercase count, as well as the space count and other count. And if you are interested, there's technically another way that you can go about doing this. You can use horizontal concatenation when you are displaying something. Again, just you want to be careful with doing that because sometimes you have to convert from one data type to another. And I will cover that in another video. The last one, of course, is going to be the other. And we simply want to display then the other count. And at this point, we should have a nice little triage of any character vector. At least to start with, we can count the uppercase, the lowercase, and so on. Let's go ahead and make sure that we have our contents variable in memory. And then we can go ahead and highlight and run everything inside of the for loop. So far, it doesn't seem like we have any mistakes. You can optionally decide whether you want to include this display. The extra noise on the console may be a good thing, at least when you're developing the script. And then ultimately you want to turn it off because it does delay the performance or reduces the performance of your script and delays the running of your script. All right, so now the moment of truth here. Let's take a look to see how our variables turned out. So it seems like we have 14 uppercase, 120 lowercase, we have 18 space, and 10 others. Now, obviously, we wouldn't want to go through and check to see that we have 120 lowercase values, but what we can do is just briefly count the uppercase one, and so there's 6 there with our Matlab, another 3 with Mat, and then Lab, so that brings us to 12. And then if we come along a little bit further here, we have a capital M in MathWorks and a W in MathWorks. And so it looks like, at least for the uppercase, that we have got this problem figured out. Now, the only thing that you could do is you can just simply check to see by adding all of these up, make sure that they reach the total character count of 162. And because of the way that we have written our if statement, it would be kind of impossible for it to not add up correctly. It would just simply tell us if we've got some mistakes in our code. And then, of course, that we can see if we turn off this display here and only leave this display, well, you get the added benefit. Let me rerun this one more time of seeing which ones didn't get caught in your if statement. In other words, what are the other characters? And you can see that this is mainly the symbols and the numbers. So we've got pretty good coverage already with only 4, or rather 3 if and else if statements. So as always, hopefully you found this video useful. This is a little bit of a departure from the numeric vectors. However, remember that the character vectors are essentially just numeric vectors in disguise, if you would, complements of the ASCII encoding. If you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.